All right, so I would ask the kids to read the directions together, which we're going to identify whether we're missing a part or a whole amount, and then we're going to solve to find the missing numeral. I'd ask the kids what a numeral is. It's a number, it's a digit. Strip diagrams. I generally, when I taught those, and we've done them earlier this year, but I hate to do it to this paper, but generally I'll tear a strip of paper like something like that, and I'll just tell them this is a strip of paper. Strip diagrams are literally strips to represent math word problems. And they're really great to use because, like I said in the video yesterday, word problems are really difficult. You give kids pictures or models and they normally knock out the math real easily. Give them a word problem, it's extremely difficult. Why is it? Because they don't see anything but lots of words. So being able to turn word problems into pictures or strip diagrams, which is another form of a model or picture, that's the whole point. So I would ask the students right here, do they think that the triangle is a missing whole number or a missing part? Hopefully they're going to say part. I would prompt them further. If you say this is a part, what's the whole amount? 900. All right, well, I will agree with that. So everyone, we're going to write whole. And this is W-H-O-L-E, like a whole amount, like a whole pizza, not a hole in the ground. Excuse me as I dig for a pen that I cannot find. A pink will work. Whole amount. All right, there's only one whole amount. So if this is the whole amount, then that makes this a part and this a part. And we're going to write part one time. Now after this, we may just write W or P's, but at least one time you would want them to write down whole or part. Why is this a whole amount? Well, I know it's a whole amount because it's the whole bar. And this part plus this part equal the whole part. For example, this piece plus this piece make the whole piece. Equations. Looks like a scary word. I'd ask the kids to repeat it. Equation. It looks like a bully word, but when you break equation apart, he's trying to tell you that he's just a sentence that uses an equal sign. So what we want to write is, how would we find a part? Well, this is when I start prompting students. Are parts big or small compared to a whole pizza? Well, hopefully they'll tell you that a part is small. I'm still looking for that one pen I want. Parts are small. Well, how do I get small in math? That's right, I either subtract or divide. Well, in third grade, all they have to worry about is add or subtract when it comes to strip diagrams. They don't see multiply or division in them. So how are we going to find this piece? We're going to do whole minus part, which would equal part. So if you look, you have the whole thing. If you take out that part, you'd be left with that other part. So we're going to do 900 minus the 265, which will equal triangle. Triangle represents a missing digit. This is what they call algebra. I tell the kids that. It's when kids cry because there's these symbols or letters in their math, and they're like, why is the alphabet in my math, man? It's not fair. And then they get all kinds of upset. But all it means is that there's a number there. We just don't know what it is. It's missing at this time. So nothing to panic. I really, really want a different pen. Poop. All right. So solve. We do not solve horizontally. And I would use words like horizontal. We solve vertically up and down. So we're going to line up 900 with 200. Now, you can do this two ways. I think I would show them this too. Poop. I'm already screwing up. Where's the whiteout? Y'all, normally I'm better than this. So I could do it this way. Is 0 enough to pull 5 out? No. And I can't grab from a neighbor, so we're going to grab 1 from the hundreds. 9 goes down to 8. When we regroup, we always bring over 10. Well, how many are there? 0. All right, so we have a full 10. However, we haven't helped out this 0, so we take 1 away and 10 come over. How many are here? 0. So it's 10 minus 5. 9 minus 6. Well, I have 6 in my head. 7, 8, 9. I always like bang my fist or bang my head when I count, because kids tend to do this: 6, 7, 8, 9, and then they're off. 6 is in your hand or in your head. I'd bang my head. 7, 8, 9. 8 minus 2. I don't try to count backwards. I have 2, 3, 4, 5, 6, 7, 8. So the missing piece is 635. Now I'm going to tell you I didn't make this one, and I highly disagree with the size, because when they're the same size and shape, they're the same number. Really, it should look more like this: 265 being a smaller section and 635 being a larger one. The other option is, if you don't want to regroup, subtract 1 from each one of them. So minus 1, minus 1. 9 minus that, and you don't have to regroup. Just a thought. All right, over here. Am I missing a whole or a part? All right, y'all say a whole amount. I'm going to agree with you, so let's write W. How do I know this? Because on a strip diagram, one side is the whole strip. If this is the whole strip, then these are a part and a part. So, if we want a whole amount, think of a pizza. What's larger, a whole pizza or a part of a pizza? A whole pizza. So how do you get bigger in math? Add or multiply, because that's repeated addition. Again, these aren't the same number, so we're not repeatedly adding. So to find the heart, and look how I use my hands, part plus part makes whole. Equation, he just wants an equal sign. So we're going to solve this by taking 389 and adding 564, which will equal the heart. We don't know what the heart is, but we know it's a missing whole amount. And again, this is algebra. We do not solve it horizontally. 500 is more than 300, so I'm going to write 500 first. So we have 9, 10, 11, 12, 13. So we're going to write the 3 and carry the 1. I'm going to connect 6 and 8, which is 14 plus 1. And I know 1 plus 5 is 6, 7, 8, 9. I do use my fingers when I'm talking to kids or modeling. And you see me go through this fast. I ask the kids to go with me, like 4 plus 9 is, they'll say 13. I'll be like, let's see, 9, 10, 11, 12, 13. I agree. I'll ask them, what's 6 plus 8? I'll wait. And I'll encourage them, hey, I want to hear everyone. What's 6 plus 8? 14. If you only hear a couple of them, don't accept that. Make them all participate. Encourage them to answer even if they're not first, because it doesn't matter if I'm first. Just because I'm first doesn't mean I'm right. I want everyone, I always praise them if I see them counting on their fingers, answering even if they're not answering right away. First doesn't mean it's right. Always do your own addition and shout the answer. I hope that makes sense. So the missing whole amount is 953. All right. Then I might call on a kid. Oh, and am I missing a whole amount or a part here? A whole amount. I agree. Everyone write W. Again, I should know this is a whole amount because it's a whole strip. This is a whole big strip. This is a part, and this is a part. All right. So a whole amount. Is it big or small? Bigger. So we either add or repeatedly add. Well, this is not the same number, so we're not doing repeated addition. We're just adding this plus this to make the whole. Part plus part makes whole. What would be the equation, Landon? Hopefully he'd say 567 plus 358. And I'd ask, is that an equation? Let me see. Equation, no, equations need equal signs. What is it going to equal? It's going to equal the fish. We don't know how many, but we know it represents a number. And then we're going to line it up vertically. 567 plus 358. I'm going to use near doubles. I know 7 plus 7 is 14. One more than that would be 15. I know 1 and 5 make 6. 6 plus 6 is 12. And that's 6 plus 3, 7, 8, 9. So our missing whole amount is 925. All right. You could call on Michaela. Michaela, does this represent a whole amount or a part? What do you think? I agree. It's a part. Now, if it's a part, John, what's the whole amount? You're right. 632 is the whole amount because 632 is the big whole strip. It's not in pieces. It's a whole thing. This part and this is a part. All right, parts. Are they bigger or smaller than a whole amount? Smaller. How do we get small in math? We take away or we split, right? Well, this is not equal groups, so it's just whole minus part equals part. So what would be the equation? 632 minus 289 equals asterisk or star. This is horizontal. How do we want to solve it, class? If they've been listening, they probably can tell you vertical. Okay. Is 2. If you have 2 objects, can you pull 9 out? No. So we're going to regroup. We're going to take a group away. How many come over? 10. 10 and 2 make 12 minus 9. Again, don't count backwards. You have 9, 10, 11, 12. And this is literally what I model with kids. But I don't just tell them. I'm asking them. All right, if we have 2, can we pull 8 out, y'all? No. So we're going to take away from 6. How many get brought over, everyone? 10 plus 2 there. 12. All right, y'all, what's 12 minus 8? And I'll wait. They'll say number, and again, if you only hear 1 or 2, say no. I want everyone. What's 12 minus 8? All right, 8, 9, 10, 11, 12. I agree with y'all. That is 4. So I make them answer, but then I model for the ones who maybe weren't sure. 5 minus 2. 5's big enough to take out 2. So we're left with 3. So the missing part is 343. All right, boys, I want y'all to read about the farmer, and while the boys read, I want everyone paying attention. So the boys read, blah, blah, blah. All right, girls, read the question, the sentence that's a question. What is the combined amount of fruit the farmer collected? All right, y'all, what are we looking for? I don't want the whole book. I want a summary. I want it shortened, important stuff only. Okay, I want a combined amount. A combined amount of what? Fruit. What fruit? Fruit collected. All right, and I always tell the kids, if I combine my hands, what am I doing? I'm putting them together. So that would represent addition. So we could solve it, but he's got apples, oranges, and watermelons. So I would ask them this. You want the combined amount of fruit. Do we know the whole amount of fruit? Do we have the total amount of fruit in here? The answer is no. We're looking for the big whole amount. We have a part that's apples, a part that's oranges, and a part that's watermelon. So in this word problem, we actually have 3 parts. These, you only have 2 parts. So I would ask the kids, what do you think one strip should be? Hopefully they'll say whole number. They might say parts. Okay, well, if they say parts, start with that. How many parts? 3. Okay, and I would tell them, this is when I would probably tell them, you know what, these models are pretty good, except see how the boxes are the same size and shape? That's really a no-no. 567 should be a bigger box or part. So we're going to make this more realistic. You've got a large 226, and then you've got a 100 and then a 52. Doesn't really matter what order. The smaller box would have the smaller number. The largest box would have the largest number. So this is really more accurate. Bigger number, bigger box. Smaller number, smaller box. So 3 parts. And then I would tell them to copy. At this point, I might get up and go walk around while they're doing that. Like making sure, did they summarize? Do they have addition? Did they break them apart? Did they do their work? Because if they aren't, you know, let them know that. Let them know, you know what? Your job is to copy. If you're not copying, then you need to come in at recess and you'll just copy the whole worksheet. You know, it's easy to do your job. All right, if are these the whole amounts or parts? Parts. Yeah, that's a part, and a part. So what does this represent? The whole amount. We don't know the whole amount. So what could we put to represent the whole amount when we don't know the answer? And if they're not really sure, pull them back. Well, here they have a heart for the whole amount. Here's a star for a part. Okay, so a triangle, I agree. Could I put F? Could I use F for like fruit? Yeah. This is algebra. You're just saying, hey, there's a whole amount of fruit. We don't know what it is. How are we going to find the whole amount? How are we going to combine? Add is right. Part plus part plus part would equal the whole thing. So remember, equations, they look like big bad bullies. Y'all say equation. What are they trying to tell us to use? That's right, an equal sign. So how are we going to find this answer? We're going to do 100 plus 226 plus 52. And it's going to equal F for the whole number of fruit. Are we going to solve it horizontally? No. Now, I would ask them to do a little bit of mental math. If you add 100 to 200, what would you get? 300, right. So 226 plus 100 would be 326. So that took care of both of those with some mental math. Then I'm going to add 52. I would let the kids know if they're not comfortable with that, there is no rule that says they can't add all three numbers together or add two numbers then another. There's no wrong way to add, just show your work. 6 plus 2 more is 7, 8. 2 and 5 is 7, 3. So our missing amount is 378 pieces of fruit altogether. Okay, there's more of these. So after they read, I'd want them to summarize that I'm looking for cookies, Denise and Mark, leftover. So I would ask the kids, if you have leftovers, when you have leftover food, is it all of the food or some of it? It's some of it. So if we're missing some of it, which is a part, that must mean we have a whole amount. So in your word problem, if you're saying we're missing a part, where's the whole amount? 368. He baked 368 for the fundraiser. So if you have a whole, that's the whole amount, which would make this a part. So here's what they did. They had a whole amount of cookies. Some of them were sold. When you sell things, they're taken away, which would represent subtraction, and then you have some left over. So to solve this, it would be whole minus part equals missing part. Now, before we do this is what ends up tricking kids, is once you give them the difference, the answer, they try to put it in the strip diagram. Strip diagrams and equations, they generally have a missing number. So, how do we do this? Well, we said we had a whole amount. So, this whole strip is 368. Now, I don't know what the missing part is. So, I mean, you can totally subtract. This part's bigger. Just make sure that one part is bigger than the other one. What could we put right here? What are we missing? Cookies left over? We could draw a chocolate chip cookie. Algebra. I have cookies. I sell this amount. These are left. Whole minus part equals part. What would be the equation, y'all? How would we solve this? 368 minus 262. Is that an equation? Why? Right, it needs an equal sign. When you do this, you're going to equal the cookies. And then 106. All right, so I'm going to read this one. When I come across the numbers, I want y'all to read them. All right, girls, read the question. The question sentence. All right, boys, what are we looking for? Total canned goods? For who? Third grade class. Total. If you go to the grocery store and they total up all of the stuff you buy, they're putting it all together. So is a total a whole amount or a part? Yeah, total is the whole thing, which means we need to get big with addition. That means her class is a part. Sanders' class is a part. Fidel's class is a part. That reminds me of the one we already did. And I go back and show kids. We've got 3 parts. Which part's the largest? The 202. So we've got a big and then medium, and I think I just broke it evenly, not paying attention. It's hard when you're videoing and not really looking at sizes. So let's try it like this. That's better. So 202, the larger the number, the larger the strip. 145, 103. And what's the whole amount, y'all? Oh, we don't know. Well, what are we going to get when we add all these? What is it? What are the numbers representing? Canned foods. So we could write CF. Now, Miss Pierce thinks CF is something totally different than canned foods, but I will not say it on YouTube videos, just in case. So, if you need a large whole amount, what are we going to do? Tell me how we're going to solve this. 202 plus 145 plus 103 will equal total amount of canned foods. So let's line this up vertically. 202, 145, 103. And here's what I would do. And if they start shouting out numbers, I'm like, no, I'm leading. You answer. 2 plus 3 is, that's right, 5. 2 5s, 10. Because I like to guide the kids to make tens and doubles. 1 and 4, 5. Like right here, 1 plus 1 is 2. 2 plus 2 is 4. They're really good at doubles. So always try to lead them to doubles and tens. All right, this big one. Girls, read us about Morgan, Tori, and Karen. Oh, start over. So-and-so's not paying attention. And yes, I would really do that. All right, boys, read us the sentence with the question mark again. All right, what are we looking for? We're looking for points Karen scored. Now, are the points that Karen scored all of the points or some of the points? Some. It says it. She scored some. So Karen's are only a part of the score. Are parts bigger or smaller than the whole amount? Smaller. How do we get small in math? We can take away or we can divide and split, right? Well, we're not splitting. We're not doing division. There's no equal grouping here. All right, so if we're missing a part, where's the whole amount? Oh, a total of, okay, so here's the whole amount. So over here on this strip diagram, I know that 110 is the whole amount of points these three girls got together. I know Tori's part was 62 points and Morgan's part was 32. We do not know Karen's part. So how many parts should we have? 3 is right. We know there's a 62, a 32, and what should we put here? K works. What's K for? Karen? Okay. How do you find a small piece? This one's kind of confusing. The reason it's confusing is because up here, when we needed one part, we did whole minus part equals part. Whole minus part, and you're still stuck with 2 parts. So you have 2 options. You can do whole minus a part, minus again, and then you'd be left with the third piece. Or what I think's easier, and I like to use my fingers, you have 3 parts. I can add these 2 together, which takes us from 3 pieces into 2, and then I could subtract those 2 pieces and get left with 1. So again, it could look like this. 110 minus 62, that difference minus 32, left over. Or combine, subtract 1 time. I like to subtract just 1 time. So to solve this, first I would add the pieces I have. This is part plus part. So instead of 2 parts, and you might do this for the kids, now you have 94 and a K. You went from 3 parts into 2. Have you still found K? No. So now you could do whole minus part to equal part. So I would do 110 minus 94. Remember that trick on the front? If you took 1 away from 10, what would you get? 9. So we could drop this down 1. What's 1 from 94? 93. And if you do this, oh, we still have to regroup. Look at that. Sadness. I wouldn't do that. I would just do it normal. 16. Karen scored 16 points. All right, here, which equation matches what we discussed? And this is what I like. Math is done in lots of ways. There's not one that shows add and then subtract. So which one of these could be right? Let's eliminate. Which one do you know is not right? Yeah, we didn't add all the parts. That's not genius. And this is adding whole plus a part. You don't add a whole plus a part. No. It's this one. Or is it? Oh, Miss Pierce screwed up totally. It's B. It's the one I got rid of first. Sorry, I hate this. This is when they go back and use a fact family. We had to find the missing piece. They're showing part plus part plus part. The 62, the 32, and the 16 make P. What do y'all think P stands for? Oh, you're right, points. So see, this is why I like doing math beforehand. I would have been looking, I was thinking it would be 110 minus 62 minus 32 minus K. You never know. Fact family. Last one. They read it. We're looking for the strip diagram used to determine total number popsicle sticks. If I want the total amount, do I want all of them or some of them? All is right. If you total up your groceries and everything you buy at the store, are you getting big or small? Big. How do we get big in math? We either add or we repeatedly add. So if we're missing the total, if we're missing all, we're missing the whole amount. So I want y'all to look at the strips. Notice that they all have the whole amount. That's a bummer. But what do I know? I know she used 47. And I knew she used 85. I want the total amount that she had before she made the tower. Well, you have some, so these are parts. So we have two parts, but we're missing the total that she had. What should we do? We should add part plus part. So let's see, what's 85 plus 47? 9, 10, 11, 12, 13. I could have gotten rid of this one. Nowhere is there a 2. That's weird. So we should have these three numbers. The part plus the part makes the whole total. So part plus part makes whole. All right, and then I put these on just for y'all to go back and like spiral. Ask them if they should carry. And then these, answer to subtraction is a difference. Answer to multiplication is a product. Addition is a sum. Division is a quotient. If you watched the video yesterday, I remember this is DQ, Dairy Queen. Or on the division house is Santa saying, quo, ho, ho, quotient.